Okay, after we have talked about the concepts about the energy balance of a closed and as well as open system, let's talk about some of the examples regarding the real situations. Okay, this should be the easiest example here. Water is being heated in a closed pan on top of a range while being stirred by a paddle wheel. Okay, the figure is shown on the right. Okay, that is what we call the closed pan. Okay, on top of a range. Okay, and it is stirred by a paddle wheel. This one is the paddle wheel. Okay. During the process, 30 kJ of heat is transferred to the water and 5 kJ of heat is lost to the surrounding air. And this paddle wheel work amounts to 500 Newton meter. Because it's work, so this Newton meter is actually joule in this case. Okay, but remember, for Newton meter, it is actually reserved for talking about the moment or the torque in the mechanics. Okay, if we are talking about the work, although it's Newton meter, we will usually use joule to represent this work. Okay, we need to determine the final energy of the system if its initial energy is 10 kJ. Okay, so actually we have all of the terms that's necessary for our calculation. Okay, so let's see the solution. I expect that you have tried this by yourself. So let's write down the energy balance equation. Okay, E in minus E out equal to delta E of the system. Okay. Okay. So if some energy get in and some energy get out, then the total change, okay, should be equal to the change of the energy inside the system. Okay, and then we need to plug in all those values. Okay. So E in, as you can see in this picture, okay, sometimes this picture may be available, but in some cases you may need to draw this kind of a schematic to help you visualize the problem. And I advise you for doing every problem regarding thermodynamics, you must draw the schematic, okay, so that you will get a much clearer idea of what's going on. Okay, in later problem, okay, there will be more and more wordings, so that you need to translate all of the data you have into the schematic so that you can have a better visualization about that. Okay, so let us see the terms. Okay, we have this 30 kJ, okay, we have this 5 kJ. This 30 kJ is the Q in, this 5 kJ is the Q out, while this 500 Newton meter is the paddle wheel work, okay, that's supplied into this system. So that we get what? We get this energy in should be equal to 30, okay, that's a 30 kJ. We will convert them all to the kilojoule, so 500 divided by 1000 kilojoule, okay, and that should be equal to 30.5 kilojoule. Okay, how about E out? Okay, we only have one term, that is a 5 kilojoule, so that after we have plugged in all those values, we get the delta E of the system to be energy in minus energy out, so 30.5 minus 5 equal to 25.5 kilojoule. Okay, and after that, we need to find out the final energy. We already have the energy change and we have the initial energy inside the system, so we can write out E final or E2, okay, whatever, equal to E initial, okay, plus the delta E of the system. Okay, remember this delta E must be final minus initial. That's the definition about delta. Okay, so equal to 10. Okay, because the initial energy is 10 kilojoule plus 25.5 kilojoule, and we get a 35.5 kilojoule in this case. But of course, conventionally, we also write it to be correct to 3 significance figures, because we expect that all of these values are measured and there should be some rounding in this data, so we will also write correct to 3 significant figures in this case. Okay, easy example, and then we will gradually go to more and more difficult examples next video.